In the previous session, I had asked you to find the number of different possible anagrams of MOOC. Can we solve this using the same concept we saw in the previous session where we made 4 slots? Let's try. As there are 4 letters, the first slot can be filled in 4 ways. After using up 1 letter here, 3 remain for the second slot. 3 ways in which the second slot can be filled. After using a letter each in the first 2 slots, 2 remain for the third slot. 2 ways in which it can be filled. And just 1 letter remains for the fourth slot. And we multiply these to get the answer. 24 ways in which different anagrams of MOOC can be formed. 4 factorial. What we saw is incorrect and a very common mistake made by students. The important thing that we need to observe here is that there are 2 O's in MOOC. 1 M, 1 C and 2 O's. So what if there are 2 O's? Will it matter? To understand this, let's assume for time being that the 2 O's are different. Let's call them O1 and O2. Assuming they are different, let's look at a few anagrams. One would be M, O1, O2, C. And another one would be M, C, O1, O2. Now assuming the O's are different, can we write the first one as M, O2, O1, C? Yes, we can, as the O's are assumed to be different. And we can write the second one as M, C, O2, O1. Look at the first pair. In reality, are they different? Is MOOC different from MOOC? No, they're the same. The 2 O's are not different. There is just 1 O in the English alphabet. What about the second pair? Is MCOO different from MCOO? No, they're the same as well. This is what 4 factorial includes. It counts each anagram twice, which is incorrect. Why is 4 factorial counting each anagram twice? The answer to this question is important. So let me have your complete attention for the next 1 minute. Assuming the O's to be different, there are 2 factorial arrangements for each anagram. The 2 factorial arrangements for each anagram are O1, O2 and O2, O1. But should we count 2? Are the O's different? No, they're not. So we should count just 1 of each pair. And that is why we should divide all possibilities by 2 factorial. 4 factorial includes all possibilities assuming each letter is distinct. But here, the 2 O's are not distinct. So we divide 4 factorial by 2 factorial. Many books will simply ask you to divide 4 factorial by 2 factorial as these are 4 letters and out of these 4, 2 are the same. But you must understand why we are doing it. In the all possibilities case, each anagram is counted 2 factorial times. So we divided by 2 factorial to eliminate the repeated anagrams. What if we had another O? Something like MOOCO? It's easy. How many letters do we have in all? 5. So 5 factorial will include all possible anagrams assuming the O's are different. But we have 3 O's here. So to eliminate the repeated ones, we divide 5 factorial by 3 factorial. So here's another one which I want you to try. Find the number of different anagrams possible for the word excessive. It's simple. How should we go about an anagram problem in your exams? The previous method we saw would be a bit tedious. So here's an easier approach. The first thing we should do is count the number of letters in the word. Same or not, just count them. 1, 2, 3, 4, 5, 6, 7, 8 and 9. 9 letters. The word excessive has 9 letters. Once we count the number of letters in the word, we should check if any of the letters are repeated. So let's go letter by letter. The first letter is E. How many times does E appear in the word? Do we see more E's? Yes, there are 2 more E's. It appears 3 times in all. Now we can move on to the second letter. It's X. It appears just once. What about C? Just once. E is already considered. S, it appears twice. S appears 2 times. I and V appear just once. And the last E has already been considered. Once this is ready, getting to the answer is very simple. 9 letters, so all possibilities assuming all letters are distinct would be 9 factorial. The letter E appears 3 times, so we divide this by 3 factorial. And as S appears twice, we divide it by 2 factorial. This is our answer. If you solve it, you will get 30,240 as the number. But you wouldn't really need to. The answer choices you would have in your exams would most probably be in the factorial form. So we can have these many anagrams of the word excessive.